Now let's see how a new node is inserted in a linked list. As we have discussed earlier, the only reference we have in a linked list is that of the head element. And one of the common use cases is to insert a new node at the head, which means that the new node to be inserted becomes the head element of the linked list. Let's see what we mean by that. Here we have a linked list with a few nodes. We want to add 5 to this linked list. So we create a new node for it. To insert this node at the head of the linked list, we need to connect the next node reference of the new node to the existing head element of the linked list, and then make the head of the linked list point to the new node. And this order in which we connect the nodes is very important. For example, if we connect the head object reference of the linked list to point to the new node first, what do you think would happen? Think about it. Well, what will happen here is that the link to the existing head, which in this case is the node with value 1, will be lost, and hence all the existing elements of the linked list will not be accessible anymore. Because as we saw, we can access the elements only through the head element. So the order in which we connect the nodes is very important. So we first make the next node of the new node point to the existing head element of the list, alright? And then make the head of the list point to the new node. Now all the connections are maintained, and this is how the list would look like after we are done with inserting the new node at the head of the list. Note that inserting a new node at the head is a constant time operation. That is, it takes O1 time to insert a new node at the head, which means that it doesn't really depend on how long the linked list is or how many elements does the linked list contains, because we are always adding the new node at the head element. So there is no traversal of the nodes required here, right? Now let's write the code to implement this in the IDE. Open the linked list class that we created earlier, and now let's implement the insert at head method. So we write public void insert at head and pass the integer type parameter to be inserted. Now inside this, we first create a new node object, and then make the next node of this new node object point to the current head, like shown here. Then we make the head of the linked list point to the new node object, making it the new head element. Now let's create a new class and name it linked list demo. We write a main method, and inside this we first create a new linked list object and name it list. Then we call the insert at head method on this list object and add the values 5, 10, 2, 12, 19 and 20 like this. Now to print the integers, we override the toString method in both the node and linked list classes. So in the node class, we override the toString method and return the data of the current node. Then in the linked list class, we do the same thing. Now here, we would like the string to print the data for all the nodes contained in the linked list, starting from the head element. So declare a variable called current, which points to the head. Then we use a while loop to go through all the nodes of the list till the current node points to a null. We get the string created from the node object and append it to the result variable and separate them by using a comma. Then we go to the next node. And finally, we return the result. Now let's get back to the linked list demo class and run the program. As you can see, all the integers held in the nodes are printed. So this is how we implement a linked list.